Hello, everybody. Doing well. Hey, Jim. My typical late start today. Yeah, I saw a Panthera puzzle and was surprised when it was not JSOMs, but it's a happy surprise. We get to do another fog puzzle. Hey, Carl. Hey, James. How you doing? Let some people filter in here. Hey, riffclown, Thomas. How's my day? Well, I got up, I recorded the Wordle, and I started stream. That's my day. I have not had a chance to edit the Wordle yet. Hey, Lapis, how you doing? I'm all right. All right, let's get started here. This is called Go the Right Way. It's by Panthera. So we have normal Sudoku rules. Oh, we do have normal Japanese sums rules. So there's a Japanese sum somewhere. There's a 6x6 grid in boxes 5, 6, 8, 9. So this is box 5, 6, 8, and 9. Okay, so that is indeed 6x6. Blue cells in boxes 2, 3, 4, 7. 2, 3, 4, and 7. Act as, so the blue cells in these boxes act as a Japanese sum clue for the 6x6 grid, giving the sum of contiguous runs of blue shaded cells within the grid. So this would be a Japanese sum clue for this column. And this would be a 2-digit clue for this column. I believe that's how that works. 2-digit clues are read top to bottom, left to right. There must be an unshaded cell between runs of the same color. Okay. Standard black dots, 1:2 ratio. Standard white dots, difference of 1. Not all dots are given. Fog rules apply. Digits will uncover as you get them right. No need to guess. This puzzle is logical. All right. Well, we've got a difference of 6 here. And this value can only be... So all of these can only be from 1, 2, 3, 4, 6, 8. So if I want a difference of 6 to this one, I could go 1, 7, 1, 8, 3, 9. 4 is not possible. 6 is not possible. And I could do 8, 2. So if 6 isn't possible here, this can't be 3. And if 4 is not possible, this can't be 8. Now across the 5, we could do 1, 6, 2, 7, 3, 8, or 4, 9, or 6, 1, or 8, 3. But these have to be consecutive. So this can't be 1 because that can't be 2. So that's not a 1. 2 could go to 1 or 3. 6 doesn't work because there's no 5 or 7 here. 7 could go to 6. 8 can't go into anything. 9 can't go to anything. So we can now clean this up, I guess. We can do 1 to 6. We can go 3 to 8, or we can go 7 to 2. So 2 goes to 1 or 4, 6 goes to 3, 8 goes to 4. I feel like this sort of, well, these aren't connected. That's kind of, this U shape here might be important. Yeah, Josh makes a good point that this is a J-sums clue for this. So we can't do 80 something. So the max of 1 through 6 is 21. So this can't be a 3 or 8 for that reason. So that's a good point, Josh. So this is only 1 or 2. So this can't be a 6. So if that's not a 6, then that's not a 7. I guess that would be true of this clue as well. Can't be 30 something. So this has to be a 1. And now we're off to the races. That's a 4. 2 goes to 8. 1 goes to 6. That works. That's a 3. We haven't revealed anything yet. Okay. This is a 7 or a 5. Three has to go to 4. I think I got something wrong because it's not revealing. Yeah, 26 doesn't work for J-sums. Oh, right, because we don't have to put 1 through 6 in the 6x6. We can do 9. We can put 9s. So we can do 4 through 9. So that would be 45 minus 6. So we can go to 39. So I should not have removed 3 from here. Or there. This still can't be 6. So this can't be 2 anymore. I guess I could do this white dot here. 1 would go to 2. That doesn't work. We can't do 1, 2 here because we have a 1, 2, 3 in these 2 cells. And so that would be way too many 1, 2, 3s. So we can't do a 1 here. 3 going to 4. 3 can't go to 2, but 3 going to 4 would be 1, 2, 3, 4 in too many cells. So that doesn't work. So I think this has to be 4, 5. I think this is 4, 5. Yeah, that reveals it. So now this is the 2. So these are not 2s. This is not an 8. 2 goes to 1 or 3. So the 1 goes to the 2. 1 would have to go to 2 and it can't. So this is 3, 6. This is a 1. That's a 3. 3 goes to 8. 1 goes to 7. 6 can't go to 7 now, so 6 goes to 5. 8 goes to... can't go to 7, so it goes to 9. And this is the last digit for the box, 6. 4 can go to 3 or 5. 3 or 5 goes to 2, 4, or 6, but it can't be a 6. 2 or 4 goes to 1, 3, or 5. Okay, both of these 3s can go to 2 or 4. 2 could go with 1, or it could go with 4. 4 can go with 2, but it can't go with 8 because there's an 8 in the row. Is Panthera here? Just let her know. All right, we've got a black dot. Okay, what's left here? We have 1, 2, 3. We need 4, 8, 9. So the 9's not going on the black dot. The 9 goes here. So what's this chain of 3? Can't be 1, 2, 3. Can't be 2, 3, 4, 3 or 3, 4, 5. 4, 5, 6 looks possible. 5, 6, 7 looks possible. Oh no, we can't do 4, 5, 6 because of the 4, 8 pair here. So, but 5, 6, 7 does look possible. And can't use 8 and 9. So this is a 6, which goes with a 3. So this pair is oh, we need a 1 that's not next to the 3. So that's the 2. So this is a 1, 2, or 4 as well. This definitely has a 2 in it though, so that can't be a 2. And then this is, we got 1, 2, 3, 4, 5, 6. This is 7, 8, 9. So this definitely has an 8 in it. I mean, I guess this is from 6, 7, 8, 9. Yeah, we found the 6 by 6. We knew it would be there though. This is a JSUMs clue, a single digit JSUMs clue. And what's interesting about that is it can't be, you can't ever have a single shaded cell in the row, because like if this was the only shaded cell in the row, then these 2 digits would be the same digit. So we have 2 digits summing to a single digit. So this is at least 3. Which is not all that helpful. But it means none of these are 1. So there's a 1 somewhere in here. This feels like it could be a 1, 2. If this was 1, 2, then this would be 4. And that would still be 3 or 5. And this would still be 3 or 5. Otherwise, this is a 1. Um, 35 is pretty high. So our outies are 10. So 35 is going to be the entire column, isn't it? Is this just whole thing green? The whole column adds to 45. These add to 10. So now we know that this is shaded. This value here is at least 4. So it's not a 3 anymore. It's a 2-digit number read top to bottom. It's 35. It says so in the rules. Hey, Eric. Outies for column 6? Okay. So this is either 32 or 34 for a clue. Now these, if this was 32, our outies would add to 12, 13, or 14. Okay, well, if this is 32, then our outies must add to 45 minus 32. Wait, no, is that how that works? I don't know. Because what if we're missing out? Well, our outies might include some cells in this column. But, try 34 first. So, if this was 34, then our outies would be 11. But 3 plus 4 plus 7 is 14. So that's not going to work. Our outies are already too big. We wouldn't be able to reach 34. So this has to be 32. So our outies are now 13, which forces this to be a 7. And then this whole column is also green. So let's do that. That's a 7. That's a 9. That's an 8. I'm worried this isn't revealing, so let's let me do that math again. So 32, my outies are 13. 3 plus 2 plus 7 is 12. Oh, so this is either a 7 with a 1 somewhere not shaded, or it's an 8, but it can't be a 9. So that's not enough to get this value. So we either have a 7 with an... Okay, so these are always shaded then. And this is always shaded because it can't be an outie of 1. But this could be a 1. And if it was a 1, then this would be a 7. Otherwise, this is shaded and this is an 8. The value of this is unaffected, but this is a 2-digit... This is now at least a 2-digit sum involving a 6, 7, 8, or 9. So, and this can't be a 9. So we can't extend further. None of these are shaded. Gray's not really going to work for unshaded here. So I'll use purple for unshaded. And these two add to this number. So this can't be a 9. So these do contain a 7. And then this can't exceed 2. This is 1. Oh, right. This can't be an 8 either, because if this was an 8, I'd have to add to 9. So this is 1 or 2, but it can't be a 2. So this is a 1. Okay. That's not a 1. We now have a 3-5 pair in the box. And then this adds to either 7 or 8. So now that these are a 3-5, yeah, this has to be a 4. Okay. Yeah, this cell is 6, 7, 8, or 9, but it can't be a 6 because of the column. So there's always an 8 in one of these two. If this was 8, 7, that doesn't work. I don't think this can be 7, because if this was 8, 7, then this would be 1, 6, and that doesn't add to 8. So this can't be 7. If this is 8, it must be 8, 9. I don't know if that's helpful, but... Yeah, in general, we have to go up. We have to be 1 higher. So there's a white dot across these. Are we limited in what we can do here? We can't do 1, 2. We could do 2, 3. Can't do 3, 4, 4, 5. 5, 6. Can we do 5, 6? I think so. But only this way. Can't do 6, 7. Breaks that cell. Can't do 7, 8. Can't do 8, 9. Ooh, if I could eliminate 5, 6, that would be very helpful. This is consecutive, and it can't be a 4, so it either goes 3, 2, or it goes 5, 6. Yeah, we do have another dot here. So the 6, 7 would go to 5, 6, 7, or 8. Oh, okay. So the point is that this is a chain of 3. So if this was an 8, we'd be forced to do 8, 7, and then this would be a 6. If this was a 7, we're forced to do 6, so this would have to be a 5. And so now this one here, we'd go 6, 5, we have to go to 4, where we go 7, 6, we'd have to go to 5. Which means one of these two is the 5, which means there's no 5 here. So this is a 2, 3 pair. This is 5, 3, 2. Okay. This is a quad, 6, 7, 8, 9. So that's an 8. This is a triple, 1, 2, and 5. Let's see, 9 can't go to 8, so that's not a 9. 7 would have to go to 6. 6 would go to 7, or it can't go to 5, so it would go to 7. So that's a 6, 7 pair, but 7 doesn't go on a black dot. So that's 6, that's 7, that's 3. This is whatever's left. Looks like a... Actually, I don't know. Oh, it's a 9. 9 goes with 8. 8 goes with 4. That all lines up. 6 goes with either 7 or 5. Can't go with the 5, so that's a 7. Hey, Panthera. Welcome. What's left for this one? So we can't be 1, 2, 3, 4, 5. So we could be 6, 7. Can't be 8, and we could be 9. Okay, we have an 18 sum in this column. How do we... could be these 3. Could be these 4. Did I start here? No, I think I have to always include the 3 and the 6 in the shading. We either have this 9 or this 9. Column 9 adds to 9. So we're not involving this 8. So, oh no, I think, okay, if we involve this 8, it's 8, 1. Otherwise, we can't involve the 8, and I don't think there's any way to get to 9 otherwise. So I think this has to be the 8, 1. Row 3 to 6. You can't use row 3 in the sum. The JSUM is just these boxes by the rules. So I'm being encouraged to look at this here. So this could be 1, 2, only this way. Can't do 2, 4, can't do 4, 8, can't do 3, 6. So it is 1, 2. That's 5 and 2. Now that 1 is not the outie here, this is green and this is 8. Pretty sure this was an 8. Let's look at it again. How do we add? So if this adds to 32, 32 plus 5 is 37. So yeah, we need 8 more to get to 35. So that's 8, 7, 6, 5. This 2 looked up, made this 3 and 2. This is 8, 9, 6. True, that's pink. This is 9 and 6. So this could be a, this can't be a 1 because it would go with a 2. Can't be 2. Can't be 3. If it was 4, we'd put an 8 here. That doesn't work. Can't, wait, what can we do? We can do 8. We can do 8 here with a 4 here, and I think that's it. That's 1 and 4. I think this has to be, this has to be green. Sorry, this has to be purple. This has to be unshaded because it can't be part of a 7 or a 9 clue. This is 3 or 5. Can't be a 5, so it's a 3. So these could be part of the 7 clue here. How about here? It can't be 1, 2. Actually, let's do this triple first. That'll make things easier. We need a 1. We have 2, 3. We need a 4. We have 5, 6. We need a 7. So this is not a 1 and it's not a 7. So this is a 4. 4 can go with 2. Hold on. 4 can't go with 8 now, so 4 goes with 2. This is not going to be 71, so this is going to be 17 for our sum. That sum is not done. We need the 2 involved. So these are all done now. I'm going to mark the sums that we've finished. Which normally I can't do, but today I can. This is a pair for the box. We need a 1 and it goes there, and we need a 9. So we know what these add to, but we might be up to 5 bigger. Actually, we know what this pair is, so that should help. 1, 2, we need a 3 that goes here, and a 5. So we need to get to 35. This is 30, so we gotta highlight all of that. Now 35's done. Wait, shouldn't these add to 10 then? You want a different color for this? I don't like any of that. This 9 is done, so these can be purple. 32 is done. I'm still confused about how this outie math works. Did I do something wrong? Oh no, this does add to 10. What am I talking about? Okay, we're fine. What can this be? It can't be 1, 2. It could be 2, 4. Actually, this is a pair. This will help. Yeah, Yeah, we need 4 and we need 5. So this has to be 4. 4 can go with 2 or 8. Actually, we don't know. Oh, we do know. It's not a 2. That's an 8. So this is a triple as well. So we've got 1, we need 2. 2 goes here. And then 3, 4, we need 5 and 9. So we know the order. So 29, these currently add to 18, it looks like. So we're going to need both of these. Does that add to 29? 18 plus 11 is 29, okay. These add to 9, that's the max. So that's 9 and 7. These are done as well. So these add to 8, so that's an 8. These are all done. These are done. I think that's all our clues. Oh, this one. So this adds to 13. And it's done. Oops. That's a 7. This is a 4 or a 6. 4 in a row. And left is 6, 7, and 9. So the 6 goes here, 7 goes here, and the 9 goes there. Nice. Cool, thanks Panthera. That was a neat idea. Can we see what the picture is? I didn't realize it made a picture. Oh, it's an arrow pointing right. That makes sense. Okay. What's next? Oh, I forgot to do a bet soul on that one. That's all right. Whoever bet 4 won. All right. So we're going to actually remind ourselves all right, this is called 159 Squared. It's by Pallando. So we have standard Sudoku rules, and we have 159 rules that apply horizontally and vertically. So let's say this is only for the rows and columns 1, 5, and 9, the ones that are marked. So let's say I put a 3 here. If there's a 3 here, what you do is you go to column 3, and that's where the 1 goes, which I picked a bad column. If you go to column 3, that's where the 1 goes, because this is column 1. So you look at what column number it is, it's 1, and then whatever you fill in there, that's where you put the 1 in that row. Similarly here, if I put a 3 here, then you go to row 3, and that's where the 1 goes. And similarly, if I put a 3 here, then that's where the 5 goes, right? Or if I put a 7 here, then the 5 goes here. So that's how 159 rules work. Yeah, I've got links for you. And those are all the rules, it looks like. So this 1 actually, and the 5 and the 9 actually do place some digits. So this is a 6, this is a 4, this is a 2, this is a 3, and for the 5, this is a 8, and this is a 4. Let's see, almost done with the puzzle then. None of those cascade, unfortunately. I'm trying to think how to approach this. Are there any global properties to this that we need to understand? Or maybe the ones that overlap, do we need to understand how those work? Like, let's think about row 1, column 1 here. It obviously could be a self-ref, and that's fine. If it was a 2, that doesn't work, because that's going to put a 1 here and a 1 here. So this could be a 1, but otherwise it can't be 2 or 3. It can't be 4. It could be 5. It can't be 6. It could be 7, 8, but it can't be a 9. So we could pencil all the intersections in a similar way. But it's just these that have that restriction. I'm wondering whether this can reference 5. So if this was 5, both of these would be 1s. And with 1s here... Wait, that doesn't work, right? Because if this was a 1, that's saying that the 5 is where the 1 is. Hold on. No, that's saying that the 1 is where the 1 is, and that's fine. Never mind. But this intersection here is actually kind of interesting. Because this is telling you where the 1 is horizontally, but it's telling you where the 5 is... Sorry, it's telling you where the 5 is horizontally and where the 1 is vertically. So, like I said, if I put a 1 here, that's fine. That self-references the column, but it's not fine for the row because it's saying that... Oh no, for the row it's saying that there's a 5 here. No, that doesn't cause a problem. No, I don't see an issue there. Well, this cell can't be 5, 6, or 7. Sorry, this cell can't be 4, 5, or 6 because that puts a 1 where there's already a 1 in the box. So this is 1, 2, 3, 7, 8, 9, naively. Is there anything else restricted about it, though? I don't know. Not 8. Right, because there's a 4 there. So this cell here, we know that this can't be 4, 5, or 6 because that would put a 1 in those cells. So this is 1, 2, 3, 7, 8, 9, but not an 8. Yeah, we need a 6 down here somewhere. Because we always have one of 1, 2, 3, one of 4, 5, 6, and one of 7, 8, 9. So the 4, 5, 6 has the 4 and 5 used already. So that's gonna place a 9 somewhere here. A 6 here would place a 9 here, and it would place a 9 here. What's wrong with that? Oh, it places a 5 here. Right, this cell can't... Oh, wait, yeah, vertically we already have 4, 5, 6 used. Okay, that makes sense. So we need... These are from 1, 2, 3, 7, 8, 9. This can't be an 8, though, because there's a 4 in the 8. Hold on. I'm at my door. Give me 1 second, everybody. Sorry about this. All right, I'm back. Okay, so the question is, what happens if this is a 7? Yeah, that's an interesting interaction here, because 7 is perfectly fine horizontally. That places a 5 here. But vertically, that's going to place a 9 here, and we're not allowed to do that because now we don't have a 1, 2, 3 in this column, in this box column. So for some reason, this can't be 7. I think that's going to be true of a lot of our kind of intersection-y dealios. So like this as well. If this was a 3, that's going to put a 1 here, and now... Oh, I guess that doesn't matter here, does it? Oh yeah, that does matter here, where I'd have a 1 and a 3 here, and that's going to put a 5 like that, right? So this can't be 3 or 2, because that's going to put... That's going to put another of 1, 2, 3 in this box row. Okay. So that's going to be true here as well, right? No, that's not true here. That might be true... Okay, this places a 1 vertically, right? This can't be 2 or 3. It's just the intersections that kind of have this issue of restriction. So let's do the rest of them. So this can't be 1, 2, 3 because there's already a 2 in the box row. So naively, we could be 4, 5, 7, 8, 9. There's a 6 in the column. But this places a 9 vertically. So if I did 7 or 8 here, then I'd have 2 of 7, 8, 9 in the box column. So I can't do 7 or 8 here. This one here, we already have a 1, 2, 3. So naively, we could be 5 through 9. But yeah, and I think that's that might cause problems horizontally if we do 7 or 8. Yeah, if we do 7 or 8, that puts a 9 here, and that's not allowed. So we can restrict that. And then let's do row 5, column 5 now. So there's an 8 already. So naively, we're 1 through 6. Can't be 1 or 4. But if I put a 5, or if I put a 6 here, that puts a 5 here, and that's too many in the box row. Or actually, 6 is just bad because that puts 2 5s here anyway. So no 6 here. So this one here, we can be 1, 2, 4, 5, 6, 7, 9. But if we were 7 or 9, we'd be placing... Sorry, if we were 7, we'd be placing a 9 here, and that's not allowed. We're not allowed to do a 4 or a 6 here, because if I do a 4 or a 6 here, that places a 5 vertically, and that's not allowed. And this can't be a 2 because there's a 3 in that slot vertically. Okay. And this can't be a 5 because that can't be a 9. That's true. Okay, so there's a 9. Okay, so this 1, 9 means either there's a 9 here or there's a 9 here and nowhere else. I don't know if that means that this can't be 7, though. I think this could be 7. Yeah. Riffclown says this is not a 3. Ah, because there's a 2 in that slot. That's true. So this can't be a 9 now, because this would have to be a 7. And this can't be a 9, because this would have to be a 6. Josh says this is not a 6. Oh, because horizontally there's a 4 occupying that spot. This is interesting to scan. All right, so this naively could be a 1. Can't be 2 or 3. I guess it could be 4 through 9. Now, I think 7 and 8 cause issues because they place 9s twice in the box. Anything else cause issues? 3 or 2 would. Pencil. Oh, these 6s do look over. That's true. All right. Yeah, so Panthera's point is, if this is a 1, that places a 9 here, which places a 5 here, which places a 1 here. So if this is 1, then that's 1. If this is 9, then it places a 5 here. So, oh, sorry, no. If this is 9, that places a 5 here. That places a 9 here. So this is always 1. Actually, I don't think they're the same. I think this is always 1. Am I doing that wrong? Let's go through both cases. This is either 1 or 9. If this was a 1, then that vertically places a 9 here. That puts a 5 here, and the 5 now places a 1 here. So if this is a 1, then that's a 1. If this is a 9, then that places a 5 here, which then, through Sudoku, makes that a 1. So this is always a 1, which places a 9 here. And it places a 5 here. The 5 places a 9 here, which places a 1 here. All right, we're making progress. This 4-5 does a couple things. It places a 1 in either... Oh, the 1 here places the 5 here. Sorry, that was just done. And the 1 here places a 9 there. Okay, we did that. This isn't a 5. What else am I missing? I got so many digits, I now have to just kind of recenter myself. We could have a 1 here and here. Or this could be self-ref. I think either works. Oh yeah, this can't be 2, 3 because we need a 7, 8, 9 in this box column. So this just means that there's a 5 somewhere in one of these two. This needs to be a 7, 8, 9. It can't be a 9. Wait, no. A 9 would be fine. That would just be the self-ref for the row. Hold on. No, wouldn't 9 require a 2 here? I don't think it can be a 9. Yeah, because this places the 9. And the 9 can only be here or here. Okay, so this 7, 8 is placing a 9 vertically in one of these two. Okay, so we need a 2 in one of these two, which places a 9 there. This needs to be 7, 8, 9. But it can't be a 9 because this can't be a 3. This needs to be 1, 2, or 3. But it can't be a 1 because this can't be a 4. We need a 3 down here, which is actually going to put a 9 up here. That matches the 7, 8. We also need a 4 down here somewhere. The 4 down here is going to place a 9 somewhere in here. That makes sense by Sudoku. What am I missing? This one here needs to be 1, 2, 3. It can't be a 1 because that can't be a 6. Right. Oof. We need an 8 in this column. If it wasn't here, there'd be nowhere for it. So this is the 8. That places a 5 here. And it doesn't place anything vertically. Oh, but this 5 is now referenced by here, placing a 7 here. There's got to be something like these are... The fact that these are related, I think, is a key deduction that we haven't made yet. This 4, 5, 6 means that there's a 5 in one of these, which I guess we knew. So for example, if this were 2, then this is 1. If this were 2, then this is... Sorry, if this were 2, then that's 2. Right, because a 2 here places a 5 here, which then places a 2 here. If this is... This can't be 3, but if this were 2, then this is 3, and that breaks. So this can't be a 2. If this was 3, then this would be 3. Oh no, that affects this one, not this one. No, you guys are right. If this is 2, then this is 5, and this is 2. If this is 2, then this is 5, and this is 3. If this is 3, then this is 5, and this is 3. Hey, Chameleon. So putting a 2 here or a 3 here... Wait, am I saying that backwards? I guess putting a 2 here forces a 2-3 pair across 2 and 3, forces that to be 5. I don't know. I'm not sure if there's a deduction out of this, but that's the kind of weird interaction that I'm thinking might be important here. Right, I know we need a 2 or a 3 here. That's why I was kind of looking at that. The 2 or 3 here places the 1 in one of these two, which we already knew, but that's going to place a 4 over here. Okay, this can't be a 5 because then this would have to be a 7. So there's a 5 in one of these two, which is going to put a 7 in one of these two, which we kind of knew there needed to be. I wonder if a 2 or a 3 here doesn't work because it's going to interfere with the ability to place the 2 or 3 here. This can't be a 2. Is that interesting? Not really. So I'm kind of thinking about how, like, if this was a 2, that places a 5 here. The 2 is going to force this to be a 3, because we need a 3 somewhere in here. And that 3 is going to place this 5 which then places this 3. So that works, as far as I can tell. I'm not going to go much farther than that. But if this was a 3, does that change things? That forces us to have a 2 over here, but then we're going to have a 5 here. So if this was a 2, that would double up. Sorry, if this was a... This can't be a 3, though. So there's going to be a 2 here, which is going to be a 5 here, which is going to be... Okay, so then this couldn't be the 2. Because if this was a 2, this would be 5, and then this would also be 3. And that doesn't work. So this would have to be a 2. This would be a 5. This would be a 2. So I think what I'm getting at is this is a 2, 3, 5 triple. Does that sound right? Maybe not. No, it can't be a 2, 3, 5 triple. What am I getting at? Maybe nothing. There's a weird restriction there, but I don't know if it's important. Maybe there's something else to find. These are a 6, 7, 9. The 7 would mean that there's a 9 up here, which would mean that this would be a 4, 6. This would be a 2. This would be the 9. Right, this is a 4 or a 6 because the 9 is here. So this is a 7, 8, 9. Ah, but this can't be a 7, so this can't be a 9. Oh, right. One of these must be... Wait, hold on. Why did I say 6, 7, 9? I think I meant 6... Oh, no, that's right. That's fine. So what are we talking about exactly? 9 here takes... Oh, right. This one can't be a 9 because that can't be a 6. That's what you're saying. So there's a 9 in one of these two. These are from 1, 2, 3, 7, 8, 9. No 9s. That's not 8. That's not 2. That's not 2. Is this helpful? So this will place a 1 here, here, or here. Which would place a 7 here, here, or here. Ah, this can't be a 1. Because that would put a 7 here. It can't be. So this can't be an 8. So we know there's a 7 here. If we know there's a 7 here, then we know there's a 1 here. Oh, no, you're right. If this was an 8, this would be a 1, which would put an 8 here. Sorry. 1, 3, 7, 8. This places 8s up here, not 7s. And that's all fine. Andrew Sarkis says 9 in row 6, column 6 puts 6s in row 9 and column 9. Right, that puts a 6 here and here, which look back into box 5. And then you can't put a 6 into the box. Interesting. So if this is 9, these are both 6, and then by Sudoku, there's nowhere to put 6 in the box. Interesting. Okay, so that puts the 9 here, which puts a 6 here, which puts a 7 here, which puts a 9 here. 8 puts a 9 here. This is a 3-4 pair, or can it be 9? Oh, 3-4 9. This 9 places a 6 here. That's true. So that's a 2, which places, oh, we have that 9. That's a 4, which places, oh, we have that 9. This is 6, which places a 6, or places a 5 here. This is now a 9. This is now an 8. 8 places a 9 here. This is 7, places 9 there. Our 9s are done. This 3-4 pair, we actually know what that is. This is 3, this is 4. Okay. There's a 7 in one of these, which means this is not 7. The 7 here places a 1 over here. That was nice. There's a 1 in one of these two. This is a pair, so we need a 2 and a 3, it looks like. And this sees the 3. So that's 2, that's 3. I could do this column, I guess. 6, 8. 1, 2, 6, 8. This is not 2 or 6. That 3 makes that a 2, which places that 1. That 1 places a 6 here. That's not a 6. This places a 1 in either 1, 2, or 8. So this can't be the 1. This is a triple. 1, 2, 3, 4, 5. We need 6, 7, 8. So this is the 6. This is the 7. This is the 8. This is 1, 7, or 8. That's not 8. This is a pair. We need 2 and 3. So that's the 3, that's the 2. It's not a 3 anymore. This can't be an 8, so this can't be a 1. So this is an 8. Leaves a 1, 7 pair here. That's a 3 now, which places this 1. This is a pair. 4 and, so we know where the 4 goes and we know where the 7 goes. This is a 1, 2, 6 triple, so this should be a pair. We need a 4. And then, what is this? This is an 8, which places the 1 here and the 7 here. That does replace that 7. This is a 4. That's a 1. I wonder if this ends up a 5. I wonder if there's some reason that these must be 1, 5, and 9 that we never figured out. Or it's just a coincidence. Let's see. This is where the 1 goes in the box. We need a 4 in the box, and we need a 6. Okay. This is done. Sorry, that's a 2, that's a 1, that's an 8, that's a 6. That's a 7. These are 2, 3, 5. These are 2, 5, 6, 8. I'm just kind of hoping Sudoku does more, so I don't have to do more indexing. It's 2, 3, 5. Well, this can't be a 5 because this can't be a 3. This can't be a 5 because this can't be a 4. So this is 3. 3 places a 5 here and here. No, not there. Sorry, that's wrong. But it does place a 6 here. So 6 places a 5 here. That's 2, that's 5, that's 2, that's 8. Okay. Not too bad there. Yeah, we ended up with a 5 here as well. In fact, every single every single intersection was of 1, 5, 9, and these ones had to be self-ref. I don't know if that was forced to be true, but it feels like it might be. But I don't know how to prove it. And we're done. There's probably some way to prove that that has to work, but this puzzle didn't need that, so. All right, thanks, Pallando. Oh, true, this diagonal ended up 1, 2, 3, 4, 5, 6, 7, 8, 9. And this diagonal ended up all 1, 5, 9s. I mean, I guess what we could do... Give me a moment. Kind of curious about this. All right, so this is what's forced by 159 rules. Interestingly, this does not have to be self-indexed. These have to be self-indexed. Okay. So not forced by the meta of 159 squared. You wanna place like a 4 here? It's pretty restrictive. So yeah, I think what riffclown is saying is that at least 2 in every row column have to be cross-index, I guess is what he said. Cool. All right. So that's why you can't exactly prove these have to self-index because they don't quite have to self-index. All right. That's enough playing with that. Panthera, that comes with the dev version of my solver. Alrighty. This puzzle is called XV Slope Thermometer VX by Zombie Hunter. Hey, Smudger. So we have standard Sudoku, but it's a 0 through 8 Sudoku instead of a 1 through 9 Sudoku. This is the bet cell, so don't worry about that circle there. How's my holiday? No holiday yet. Oh, day. My day's all right. I woke up, started stream. All right, so slow thermometers. Digits stay the same or increase from the bulb to tip. Bulb end to be determined. So 5 thermos, 2 X's, 2 6 cell forming an X and a long sideways V. Yeah, so we have these lines are thermometers, slow thermometers. So digits have to stay the same or increase as you move along them. But we don't know which end is the bulb yet. So we don't know which end starts the sequence. Standard XV modified VX, no negative constraint. So cells separated by an X either sum to 10 or they multiply. Product immediately follows, no leading 0. Is it toroidal today or not? I wonder. So let's take these two. These could just add to 10. That would be fine. But 2, 8, they add to 10. That fulfills the constraint. Otherwise, we could do, say, 1, 7, or let's do, 3, 7. That multiplies to 21. We put 2, 1 here to show that that was the product. So 3 times 7 is 21. So that's how X's work. We could also do them vertically. 1, 7, or 3, 7, 21. We could do that. V's, if the V is horizontal, it's always adding to 5. If it's vertical, then either they could add to 5 or it's an inequality. So we could do, say, 1, 4. Those add to 5. That fulfills the constraint. Or we could do 3, 1. 3 is bigger than 1, so that's fine. No torus. So these must add to 10 because there's nowhere to put the product. All right, so those are the rules. Let's see what we want to do here. So horizontal V's are always a good thing to just mark up. And remember, there is 0, so we can do 0 through 5. Which means these are a 6, 7, 8 triple. This is a true add to 10, but I don't know quite what to mark in there yet. Okay, right. So X's you can never put a 0 or a 1 on. Because you need to do, with a 0, you could have to multiply by 0, because you can't add to 10 with the 0. So you'd have to multiply by 0, and then that would put, like, if I put a 0 here, I'd have to multiply by 0. I need another 0 in the row. And I can't add to 10. If I do a 1, there is no 9, so I can't do 1, 9. And if I do any other digit, then I got to repeat that digit. So no 0s or 1s on any X's. Does that come in handy anywhere? Nor 5s? No, you can put 5s. You can do like 5 times 4 is 20. This here, though, this is an X, so it's 2, 3, 4, 6, 7, 8 only. Okay, so if the bulb were here, Okay, the point is that 8 can only go on the end of a slope of a thermo, if it's a normal thermo, and this is a normal thermo because it's all in one box. So this can't be an 8, because if it was an 8, it wouldn't be at the end of the thermo. Now this being a 6, 7, I think prevents this from being a 6 or 7, because this is 2 away from this one. So it's going to have to be, and it's going to have to be big. Okay, this is the thermo tip then. And it's an 8. And so we're going to go 8, 7, 6, and then that's a 7. Ice Cube, I don't see why this would be limited. Okay, so what do we want to do with this? I mean, this could obviously just be a 2. Oh, 5, column 6. Oh, right, no 0 or 1 on here. That's true. Okay, so let's look at this. If obviously this could be a 3, just because it's an X. But if this was a 2, then we'd be 14. That doesn't work, because 2 can't go with 1 across a... That doesn't sum to 5. So this can't be a 2. If this was a 4, that would be 28. 4 can't go with 2. If this was a 5, 5 would have to go with 0. That doesn't work. This has to be a 3 with a 2. I'm almost positive. I should be super positive, but... The bulb end is at the end of the line. You can't put a bulb end in the middle of a thermo. Otherwise, it's 2 thermos, and he said explicitly that there's only 5 thermos. And he listed them. Right, this can't be 0 or 1 because it's on an X. So this can't be 4 or 5. I guess the point is, if this isn't the bulb, then it's the max. So could this be a 5 as the max on this long thermo here? So we could do 5, we could repeat the 5, we could repeat the 5 again, we could go to 4, we could repeat the 4, and then we could go to 3. I don't see a problem with that. Other end of the thermo is also an X. Okay. I see. Okay, well, these are in the middle of a thermo, so they're not going to be zeros. That's true. So we're not 0, 5. We have to be 1, 4 somehow. How's that going to work on these thermos? Zero's not in the middle of the thermo, so that's 5, that's 0. That's a... wait. So this is just a greater than, right? So this is between 1 and 5. So this, sorry, between 0 and 5. So this is 1, 2, 3, 4. It's not a 2. And this is bigger than 5. So this is 6, 7, or 8. It's not a 7. This can't be 0. This can't be 5. How are we putting a 1 on one of these thermos? It's got to be... well, both ends of this thermo are not 0 or 1. So this has to be the 4, and then this has to be 1. But I don't know how that works for this thermo. I think I don't understand the rules. How can we possibly put a 1 on... okay, so we can do 0, 0, 0... well, we can do it here. We can do 0, 0, 0, 1. We can't do 0, 0, 0, 1 here, because then this has to be the 1. So this is 0, 0, 0, 1. And then this is a 4. This is no longer 0. So that's not a 5. So this is, let's see, minimum 2, 2, 3, 4, 4. So this is 4 or 5. Well, I guess 4 or higher. That's not helpful. Zero in box 4. Right, this has to be bigger than 1. So this is the 0 for the box. So we have a triple left. We have 2, 3, and 5 left. Any of which I think works. Okay, so let's look at this. 2 is obviously okay because that has to 10. 8 times 3. Hold on. Let me fix this here. 0, 5, 2, 0, 5, 2, 3, or 2, 3. Okay. If we were 8 times 3, 8 times 3 is what, 24? 24? So we'd be 8, 3, 2, 4. But then that's an X, so 2, 4 would have to put 6 here, and that's not allowed. So this can't be a 3. If we were 8, 5, that's 40. We'd be 4, 0. Can't put a 0 on an X. So this has to be a 2. These are not 2s. There's no way this is multiplying. If this was multiplying, we would need to multiply to a single digit, and that doesn't work because we can't be 6 or 8 or 9. So this is 6 or 7 adding to 10. This 3, 4 now goes with a 1 or 2. Almost last one at 9. Yeah, we're so used to having 9. Can this go up from here? We'd go 8, 8, 8. I guess technically these could all be 8s. Is there a reason it couldn't be? Either all 3 of these are 8s or these 2 are 8s. So those are the 8s for the columns. This can't be an 8. Row 4, column 8. What about it? Row 9, column 3. Can't be 3 anymore. True. So 8s are somewhere here. Doesn't matter. Means that there's an 8 here. True. Where does green go in box 5? We don't have 6 or 8 placed yet, so it goes here. That's a 6 or 8. So 5 is up here, because it can't be here. Which means this is a 3. Okay. So this also needs to go in this box. I guess it's here. So that's not a big deal. Never mind. True. We need a 1 in this row. There's a 1 in this box already. Can't put a 1 on the X. This can't be a 1. So the 1 goes here. That's not 1, so that's not 4. These are from 2, 5, 6, 8. There's a 2 up here as well. See, I don't even know which way this thermo's going still. Okay, so yeah, people are saying this can't be 5 because 5 can't add to 10. And if we were multiplying, this would need to be a 0. So yeah, this is not a 5. This could be a 5 if this were... Wait, hold on. That would be way too big, though. This would have to be a 14. So this can't be a 5 either. So this is the 5. And now we know this increases. So this is from 5, 6, 7, and this is from 6, 7, 8, but this can't be an 8, so this can't be a 7. If this didn't repeat the 3, we know this increases, can't be 4 or 5, so it would have to be a 6 or, I don't think we can be a 7, because we'd be 7, would a 6 even work? 6 doesn't even work, so we'd be 6, 8 here, because this can't be 7, and then, yeah, so this has to be the 3. So this is not a 2, 3, oh, sorry, this doesn't have a 3 on it, but we don't know much more about it. Oh, it doesn't have a 7 on it, because we know these add to 10. Four in row 4. True, 2, 6, 8 triple, that's a 4. Okay, so how does this work then? This could be a 6, that would be add to 10. If this was a 2, then I guess that's an 8, and that actually works pretty well. If this was an 8, 8 times 4 isn't going to end in 1. So this cannot be 8. So either this is a 6, making this 8 and that 2. So if this is 6, that's 2. Otherwise, if this is 2, that's 8, that's 6. So this is never 8. Wait. Yeah, that's true. This is never 8. If this was an 8, this is a 6, this is a 2, and now this X doesn't work. So this is never 8. This is a 2, 6 pair. Green is 8. That's not 8, that's not 2. That's not a 4 now. Yeah, green's always 8. But this could be either now. 2 or 6 works. So for this X, we know this adds to 10, right? Because we're not multiplying to 7 or 70 with an even number. Or 7's prime anyway. So this is all that to say this is 4 or 8. But it can't be an 8 because that's way too big for the thermos. That's 4, that's 6, that's 2. These aren't a 4, 6, so they are a 2, 8. So we can't put 2, 3 here. This is increasing, so that has to be an 8 now. This is 5, 6, and this is 5, 6, 7. Oh no, this could be 7 as well. So we can double up the 7. This is a triple. Let's fill that. 0, 1, 2. We need 3, 6, and 7. Don't think I know much about those. This is decreasing. So this is less. This is 6 or under. So this is 6, 5. Can't be 4, 3, 2. I guess it could be 1. No, if it was 1, then that puts a 0 or 1 onto an X, and that's no good. So it's not a 1. Right, we can't put a 0 or a 1 on this X at all. So the question is, where does 1 go in the column? It goes here. Good spot, Carl. This is a triple for the row. We should do that because I think it involves a 0 and a 1. So this is the 1, this is the 0, and this is whatever's left. 7. It might, okay, so 7 could go with 3 because they could add to 10. Otherwise, we're multiplying to 42. Isn't that 7 times 6? Or am I, no. 7 times 7, though. We can't do that. Oh, it is 7 times 6? No, 7 times 7 is 49. Okay, so 7 times 6. So we could do 666. For some reason, I was like, yeah, that's 7 times 6, and then I was like, I second-guessed myself. But anyway, thanks for confirming. Oh, that's annoying that it can be 666. How about this here? This is just bigger than 2. Works with anything. 1 in column 8 can be placed. Yeah, 1 doesn't go here. 1 doesn't go here. Wait, what keeps it out of this cell? Oh, there's a 1 in the box. Oh, true. So, yes, this is the 1. That's a 4. What do we have left? We've got the 0 left. This has to be the 0. And then 3, 5, or 6. So I'm wondering about this multiplication here. If this was a 5, we'd have to do 5 times 6 is 30. And that actually works. No, it doesn't. Oh, no, it does. We do double 5 here. Yeah, it does work. It actually works perfectly. I bet that's what it is. 1 in box 2 by Sudoku. Yep. And then here. And here. Okay, so this is 4, 6, because we're not multiplying. That's a 7. Okay, one of these has to multiply the 7. And I don't think we're doing something times 7 is 10. Or 1. So this is a 3. And this multiplies the 7. So this is going to be the tens digit. Let's fill this column first, actually. Oh, hold on. We got this 5 and 0. Okay, let's fill this column. 0, 1, we need 2, 3, 4. We have 5, 6, 7, we need 8. These are not going to add to 5, so this has to be bigger than this. So this has to be the 8. Now we have a 2, 3 pair, and now this is 4, and now we know that that multiplies to 28. That works perfect. This is a 5 or a 6, and these are 7 and 8. We know the order. All right. One of these is multiplying. So we either have 8 times something is something 1, which isn't going to work. So this has to be a 2. And now we're doing 2 times 5 is 10. Hey, Carnival Fun. How you doing? Let's see. This is a pair. 0, 1, 2, 3. We need 4 and 7. The 4 goes down here. That's the 7. I feel like we're wrapping up. We need a 0. That goes here. And we need a 2, it looks like. Okay, yep, this is a pair, so 4 and 7 are left here, so we can fill those. These can't multiply because they're at the edge of the grid, so this is just going to be 6 and 3. Ah, this is a 6. 6 times 5 is 30. It did end up being what I thought. Just finishing what's left here. We need 3, 6, 7, 8, 9. Or sorry, 3, 6, 7, 8. So the 3 goes here, the 6 goes here, 7 and 8. And we're done. Nice, thanks, Zombie Hunter. I think I'm getting a little bit better at this XVVX thing. Yeah, it went quickly. Can I get rid of this start puzzle screen? Canon settings. Marble Run. What's that? I don't see the settings. All right. It's not important. It's just with my relayouting, it appears in an inconvenient place for me. Gameplay, don't start paused. Ah, there we go. Cool. Okie dokie. This puzzle is called Steeples. It's by Derektionary. We have normal Sudoku rules. In addition, successive digits along green line must differ by at least 5. So standard German whispers lines. So if I put a 4 here, this has to be at least 5 different from 4. There's only one number that can do that, which is 9. But now from the 9, this needs to be at least 5 different from 9. So I could do a 2, that's 7 different, that's at least 5. And then from here, this needs to be at least 5 different from 2. I could do a 7, that's exactly 5, or I could do an 8 if I want. So that's how those lines work. Digits in cages can't repeat, must sum to the number on the top left. So standard killer cages, so digits can't repeat in the cage, so I can't put a 1 here and a 1 here, that breaks the rules. In addition to that, if we summed all the digits we place in here, they would sum to 42, which is the clue on the top left there. These would sum to 40, etc. Let's see. So 42 and 7, there's only one way to do it. It's 3 through 9. This isn't a 5. This can't be a 6 either. In fact, the low on these can't be 5s either. The low on here, if these were low, they'd be 3-4 pair, which would force this to be 9. So if this is high, it must be a 9. If this is low, it would be a 3 or a 4, so this could not be a 6 or a 7. Isn't quite good enough. 38 and 40. 40 has 2 ways. We're always going to have a 5, 6, 7, 8, 9 in here. Oh, this can't be 4 because it would be double 9. That's true. Oh, hey, Nicholas. How you doing? Right, so these two cells here in purple, where do they go in this box? They can't repeat in the cage and they can't repeat here. So they go here. Which means where do 1 and 2 go? They have to go here. That's a neat geometry. So we kind of got the same deal going here. These are blue and these are orange, which means these form a set of 6 distinct digits. Which could be worth noting. Oh yeah, please do like the stream if you haven't. So maybe I shouldn't use blue and orange here though, because I want to use those for low and high. So let's use gray here, and let's use red here. And these are low digits. So this is a high digit, this is low, and this is high. So this 38 cage is missing a high digit. It's missing a 6 through 9. The only way to do that is 2, 3, 4, 5, 7, 8, 9, with this being the missing 6. Another way to put that is the 38 cage always has 7, 8, 9 in it, so this has to be 6, this has to be 1. And this is now 2, 3, 4, 5, 7, 8, 9. These can't be 5s. This can't be a 4. This has at least a 3 on it, so this can't be 7. So this has, sorry, what am I saying? This is also missing the 1, so that's the 1, that's 2, that's 1. So that's low. There's probably something similar happening here, but I'm not 100% sure yet. The 40 cage can't be missing a 1, so it must have the 1, so it is this one. It is 1. So the 2 digits it's missing are 2 and 3. So we can place those. And so these are 1, 4, 5, 6, 7, 8, 9. These are not 5s. This isn't 6. Oh. Actually, if this was low, it would be 1, 4 pairs. This would have to be 9, so it's not 6, 7, or 8. This can't be 4 either. Red can't... Oh, we can't put a 1 in red. So now we know this is a 9. This is a 3. This is neat. So these are not high. These are low. There's a 1-4 pair. So now these can't be 1s or 4s. Threes can't repeat in this cage. 9 can't repeat in this cage. 1-4 pair also applies to the box and the cage. So these are... Right, these are from 5 through 9. So this has to be high. So this is a 3 or a 4. This is low. So these are high. These are not 4s. That's an 8-9 pair in a bunch of places. These now can't be high. They have to be low. So this is high and it's an 8. This is just resolving. I think I should get rid of these colors now. Do I? Not yet. We need an 8 in gray. 2-3 pair in the box and everything. Probably missing. This is a ton of cleanup. Sorry, I haven't looked at chat. I'm just cleaning up. This is next to a 3 or 4, so it's only 8 or 9. This can only be... Oh, this can't be 1, 2, or 3. So this is 4, 9. And this is high. This is 6, 7, 8, or 9, but it can't be a 6. Oh, wait. 4 forces 9 on both sides. Never mind. So this is the 5, 6, 7, 8. It's not a 6, so that's not a 6. So let's... we don't need these being red anymore. We can just say... Oops. We can just say that the red is these two. Right, the 8-9 pair does see this as well. Okay, what am I missing here? If this wanted to be low, it would have to be a 1, which is interesting. If this wanted to be low, okay, so if this was low, this would be high, this would be low, this would be high, okay. So if this was low, it would be a 4, and it can't be. So this must be high. It can't be 4 because this would be double 9. So now we know how to color this. These are all blue and these are all orange. So this is low and it is a 1. So what do we know about that? These are from 6, 7, 8. I think these could be any low digit. Oh, that can't be a 1 apparently for the row. And so now these can't be 6s. These are from 7, 8, 9. So now, yes, this one sees all the lows. So these are high, and these are low. So this is from 6, 7, 8. It's not going to be a 6. That would double up the 1. Sorry, these 1-4s are low. We know purple's not going to have a 6 in it, so this is not a 6. Do we know anything else? Three, 4, 5, 7. Clean up red, pink, gray. You get a 4, 5, 7 triple. Right. Gray can't be 9, so that's not a 9. These are from 4, 5, 7, 8. So this is a what are we missing here? 5, 7, 8, 4, 5, 7. Where's the 4, 5, 7 triple? Oh, right. This is a 4. That's low, and it's a 4. So that's 9. So that's 8 and 9. This is 6, 7, or 8. These 8 corner marks look left. True. So that can't be 8. 5, 7 pair puts a 4 here. So that's going to do a few things. That means that these can't be, sorry, one of these is 4. This is a 4-8 pair. We know that from gray, which means that this is a 3. So now we don't need these to be purple. So this is 5-7. That's not a 3. This can't be a 4 because that can't be a 9. Tempted to clear the coloring at some point soon. One of these is 9. I don't think that matters. Hide in one of these two. Clearing the gray is a good idea. I guess one of these is pink, one of these is red. I don't know if that matters. All right, where's 9 in this column? It's one of these two, which means that can't be 9, which means that can't be 4. I feel like this line's going to be key. If this were low, it would be a 1 or a 2. If it were high, it would be 6, 7, or 8. Can't be a 6, because that can't be a 1. If this were low, it would be a 2 or a 3. If it were high, it would be 6. Can't be 6, so it would be 7. It would be only 7 if it were high. A 7 would force this to be a 2. This is 2 or 3 if it were low, and if it were high, only 7 as well. So one of these is 7, which makes that an 8. Oh, 3 doesn't work because that would be 7. And 3 doesn't work here because that would be 7. So that's a 2-7 pair. So this, if it were low, could be 1 or 2 only, because it would be by 7. If it were high, it would have to be a 7, can't be 8, it could be 9. Oh, but it can't be a 2 or a 7 because of the 2-7 pair in the box. So this can't be 2 or 4. It's 1 or 3. I guess I could put 5, 6, 7 here. Why not? This 5-7 pair means that's not a 7. True. 8 by Sudoku. How's it? Oh, there's a hidden 8 there? True. These 8s all look in. So this is an 8, and that resolves to 7 and 1 and 9. 3 and 2 and 5. That's quite the hidden. That was extremely useful. That's an 8. I don't think I'm going to color too much more here. If I fill 2, 3 here, I don't think I need any of these colors anymore, other than the reds and purples. All right. I do more with 8s. One of these is 8, I guess. Not really. True, 3 is placed in this box, and then there's a pair remaining. 5 and 6, not resolved. This is a 1 now. That's 4 and 1. This is a pair. We have 1, 2, 3, 4. We need 5 and 6. We have a X-wing on 5s here, so these can't be 5. 4 in this column can only go here. Good spot to Carl. I guess the box as well. This is a triple. We need 1, 2, and 7. This is a 5 or a 6. Nice spot. 5, 6, 7 triple here from Bulgarian. That's a 4. Oh, and that's not a 7. So is this 1, 2, 3? It looks like it. That's a 1, 2, 3 triple in this box. Which places the 4 here. Places that 4. 4s are done. This is 5, 6. What else? 5, 6, 7. One of these is a 7. Oh, we have a 5, 6, 7 triple here now. So the remaining, that is a triple. So we need 2, 3, and 9, it looks like. Right, we have 5, 6, 7, 8 here. Yeah, the other 2, 3 in this column goes here. So that's a 1, 2, 3 triple. So that has to be a 9. So we have 1, 2, 3. This is 5, 6, 7. Oops. Triple in column 5, 5, 6, 7, triple in column 5. It means this can't be 7. And I need the 8, 9. So this is 8, this is 9. 9s are done, apparently. So we have 1, 2, 3. We need 5, 6, 7. That one goes here. We now have 5, 6, 7 here. So this is 2, 3. This is 5, 6, 7, 8 for the box. Hold on. This has to be purple, so it can't be a 6. And then red could be either of these. Yeah, almost fully pencil marked. Might as well finish, right? I just don't think this is all that restricted, but maybe it is. So it can't be 1, could be 2, can't be 3, 4, could be 5, 6, 7, can't be 8, 9. And this one can't be 1, could be 2, 3, can't be 4, could be 5, 6, 7, can't be 8, 9. We do have this 5, 7 pair, so those can't be the 5 or 7. All right, what am I missing? Something with the whispers? Oh, true. The 40 cage needs a 7, so those point down. That's not a 7. Hey, Jessica. Welcome. Quad in column 1 gives a 5, 8 pair. So I guess what we're asking is where do 5 and 8 go in column 1? And the answer is only these two, so that's not a 6 and that's not a 6, 7. Hmm. .42 cage. True. 42 cage needs a 7, so one of those is a 7. Now we have a 5, 6 pair, so that's a 7. So that is not a 7. That's a 2. 1, 7, 3. Okay. Pink is 5, which means red is 7. I don't need those colors anymore. And we're going to follow Sven around for a bit. Oops. Literally just telling me how to finish the puzzle. And we're done. Very cool puzzle, Derek. I enjoyed it. Only took 25 minutes. Betzel was a 3. Congrats, Bremster. And Panthera, I think. Alrighty. Riffclown, you're still around? Yeah, I see you talking. Just a button to auto-solve all singles. Singles to the end. All right, I did the links, blah, blah, blah. Okay. This puzzle is called Skyscrapers in Nottingham. It's by riffclown. So we have irregular Sudoku rules. So instead of the normal 3x3 boxes, we have different outline cells. So we still have 9 regions that work just like the boxes, but they're irregularly shaped. I might color them. Standard arrows, so digits on an arrow sum to the value in the circle. So if I put 2 and 2 here, that's a 4. External clues are normal skyscraper clues. So ignore my column markings here, but these bigger numbers here. So a skyscraper basically is saying, if you were standing on that clue, looking in that row or looking in that column from that vantage point, and the numbers represented the height of skyscrapers, how many skyscrapers could you see? So if this was, say, a 6, then I could see the 6. I always see the one right in front of my face, but then I could only see 7, 8, and 9. So I could do, say, 5, 4, 2. But then if I put an 8 here, that's going to break this clue because I'm going to see a 9 somewhere, and I would see the 6, 8, and 9. So I'd need to see the 9 before I got to the 7 and the 8. And this would work. I'd see the 6 and the 9 and nothing else. So that's how skyscrapers work. And that's it. Those are the rules. I think I will actually color our regions here. So let's use one of the color palettes here for that. Are these dark digits going to be... This blue is going to be tough. It's a bit dark, isn't it? All right, I don't have names for all these colors, but... So these 4 cells are the same as these 4. This is 6, 7, or 8. So this has a 1 on it. Yeah, so how big can this be? If this was a 4, or sorry, I guess if this was a 5, because it can't be 3 or 4. If this was a 5, we'd only be able to see 6, 7, 8, and 9. So that would only be 5 big. So this has to be a 1 or a 2. And then our 9, we could go 1, 2, 3, 4, 5, 6. The 9 has to be in one of these 2 cells. Oh, actually, the 9 can only go here. So the 9 is placed. And so now we have to strictly increase because we won't see these 2, and those are the only 2 we're allowed to not see. So this could be 2, 3. It's like a thermo. 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. Which means this cell is 7, 8, or 9, but it can't be a 9, so that can't be an 8. And this is a 1 or 2. So if that can't be an 8, then this can't be 7, 6, 5, 4. 9 in yellow is now over here. And then 8 now hides down here, along with whatever's missing from this chain. Ah, but this is a 3 clue. So if this were an 8, we'd only see 2 cells. So that's an 8. So now this has a 2 in it as well. So we know that this isn't 1 or 2. So 1 and 2 have to be in the skyscraper. So we got to do it that way. And then 1 of 3 or 4 is also present here. So I'm not sure exactly how to mark that, but oh, a 6 must be present as well. Is that interesting? So we know that there's a 6 in one of these two. We do have a bunch. This is a 2 clue. We see this one and the 9, and that's it. So this has to be pretty big. We could fit 1, 2, 3 here, I think. So this is at least 4, but it sees a 4. So this is 5, 6, 7, or 8. This we see 3. So this can't be an 8. I don't know. That doesn't really limit it. Let me know if anything's hard to see and I can change their colors up. Row 5, column 7's from 7, 8, 9. All right, because 1 and 2 are used in the region. So are 6 and 7. So these are from 3, 4, and 5 only. And I think they must have a 5. So this is either going to be 5, 3 or 5, 4. So this is 8 or 9. An interesting thing is that this cell, if it's a 6, forces this to also be a 6. So if this is a 6, this is a 6, and these are the same. But I don't know if that matters. If it's a 7, if it's a 7, it's the same. Because if this is a 7, then this is a 6, and so then the only way to add to 8 would be to put the 7 here. Pretty sure. Maybe not. Maybe we could fit the 7 over here. We know that these 4 cells go here. These are connected in an interesting way. If this is an 8, then this is 3, 5, which means this is 7. So if this is 8, this, yeah, and that's broken. So if this is 8, this is 3, 5, which means this is 1, 2, 4, which makes that 7, but now 8, 7 sees this cell and it has no value. So this has to be a 9, and this is a 4, 5. That places this 9. So this is 1, 2, 3 adding to 6. That's a 7. So that's 8 and that's 1. So now we have to have a 3 in this column, that's here. We have to have a 6 in this column, that's here. This is a 4 or a 5. That's good progress. So how are we adding to 8? The obvious thing is to do 7 and 1, but there may be other options, because this could be the 7. This would be a 4 or a 5. We couldn't be the 4, but we could do... and we can't be the 5 because it would be 5, 3, and that breaks here. So this has to be 7, 1, and this is the 4, 5. Oops. This is a pair. We have 1. We need 2, 3 here, and we know the order. Let's see. Claudia is snoring. I don't know if you can hear it. It's pretty loud. All right, the pink regions 1 is somewhere in here. One of these. That just means this can't be 1, so that's a 2. Let's see. So that puts a 2 in one of these two. I guess I could mark 1s in here. We have a 3 in one of these. The 2 and the 3 are looking over, so that's a 2-3 pair. This is just what's ever left for the row. We have 1, 2, 3, we need 4, 5, 7, 8. One in this region, I'm being told. Maybe we're talking about this region. I'm not sure which region we're talking about. We know that the 1 is in one of these cells, which does line up with these ones, but I don't think that does anything useful. Oh, this can't be a 1 because this would be a 3, and that doesn't work. So if that can't be a 1, then where does 1 go in this column? And the answer is right here. Okay, so now, 3 doesn't do much. So 1 is not here and not here. So 1's in one of those 4 cells. Do we want to ask how we add to 9? Is that interesting? Can't be 2, 7, 3, 6. We could do 4, 5 like this, I think. We could do 5, 4. We could do 6, 3. We could do 7, 2. And that's it. Okay, more options than I hoped. This can't be 213. This could be 224, it looks like. Oh no, this can't be a 2. Can't be 23. So we could be 246. We could be 257. We could be 268, and we can't be a 9, so that's it. One in this row, because brown has a 1, is in this salmon color here. Eight sees over here, so 8's in one of these. Is that helpful? Probably not. 9 joins the 1 in salmon. How are we seeing that? Oh, because there's a 9 in brown as well. This must be fairly large. True, this is at least 5. So if this was not 1, it couldn't be 2 or 3. So the best we could do would be 5, 4, 9. Otherwise, this is a 1, in which case we'd be 5, 1, 6, or 6, 1. Oh, it can't be 6. We could be 7, 1, 8, or we could be 8, 1, 9. 9's pencil marked in row 8. Oh, right. Salmon claims the 9 down here, so this can't be a 9. So this must be a 1, and this can't be an 8. That eliminates 1 from these cells. And from here. Good spot, Garion. Using my own pencil marks against me. All right. Well, we can say that 6 is in one of these as well. If we can find one more that's occupied in there, then that would be helpful. But like a 7 or something? I don't know. 7's placed in row 1? Really? Oh, 1 in row 7. I mixed up. I completely read that wrong. 1 in row 7 makes a lot more sense. Can't be in green, can't be in salmon, can't be in brown, can't be here. Yes, that's a 1. Row 2, column 7 can't be a 6. 2, 6, 8, something wrong with that? Oh, because these 6 is on brown point up, right? So that's not a 6. So that's not an 8. So 8 and 8's down here. These 3 or these 3? So that means we can't put a 1 here. So this is a 1. How many 1s do we have? We need a 1 in this row, we need a 1 in this row, and that's it. So where's the other 1? Where's the region that needs a 1? This, what do we gonna call this? Maroon region? Needs a 1 in one of these two. 3 in brown, I'm being told, is interesting. 3 in brown is somewhere. I don't know how to narrow that further. We have some errors we haven't even looked at. Okay, so this doesn't have a 1 on it. It can't be 2, 3. That breaks this. So the smallest we are is 2, 4, which adds to 6. So this is 6, 8, or 9. But the 9's claim. So we actually have a 6, 8 pair in salmon now. 6 would require 2, 4. 8 could be 2, 6. No, well, it would be a 6 here with a 2 here. Or 3, 5. Which I think could go either way. So we have 2, 3, 4, 5. Ooh, almost. 2, 3, 4, 5. Row 7, column 1 can't be a 5. Oh yeah, we do have skyscraper clues, which I have been completely ignoring, other than the break-in. So, which skyscraper clue are we interested in here? If this was if this was a 5, we'd be forced to... Wait, would we? What are we talking about here? Can't we do 5, 2, 4, 3, 9? We have to hide the 6, 7, 8 behind the 9. We can't. Right. If this was a 5, then 6, 7, 8 need to hide behind the 9, and they can't. That's a very simple way of seeing it. So that's not a 5. 8 makes the most sense here, but it doesn't have to be. In fact, now any digit this is fulfills it. Interestingly, if this is a 6, then this is a 7, 8 pair. I don't see an immediate reason that would be problematic, though. This can't be an 8, so 8 is limited in this row to these two cells. We have a 5 here. We have a 2 here. So this can't be 7. Can't be 6. So this is 5 or lower. And then this is... Oh, wait, hold on. No, this is a 2 clue. I was thinking a 3 clue. This needs to be bigger than this one. That's the relationship. So this can't be a 1. So this is the 1, and this is the 1. So this can't be 2. Can't be 3. So it's from... Can it be 4? If it were 4, this would have to be a 2, and I think that works. So this is 4 or 5 or 7. Eric has an interesting point, which is if we omit both 2 and 3 from this arrow, then it adds to, it's 4 plus 5, which is 9. So this is a virtual 2, 3 pair, so this can't be a 3. So these are from 4, 5, 6, 7, 8, I guess, naively. But this can't be an 8. I think this can't be a 4, because it needs to be bigger than this one. Well, no, actually, if this... Yeah, if this was a 4, this would be 5, and this would hide both of them. So this can't be a 4. If this was a 5, this would be a 4, and this would still hide both of them. So this can't be a 5 either. Okay, so Nicholas is saying I need to place 2, 3, and 4 in row 5, which is true. And I have these places for it, but this can't be a 2. It can't be a 3. Could it be a 4? So what keeps this from being 4? This would be double 2. I don't know what keeps it from being 4. I think double 2 works. It does force this to be 3, 5, making that 8, making that 6, making that 5. I think it works though. Yeah, I mean, I was trying to eliminate double 2, but I don't know if I can in my head. Okay. This is smaller than this though, so this can't be 7. Can't be 3 either. So it's 2, it can't be 3. Could be 4, 5. Actually, if this was 5, this would be forced to be 4, and this would have no value. So this can't be 5. Oh, sorry, this is less. This is less. So 5 would force 7. Hold on. I think that's okay. So this is 2, 4, or 5, I think. So the 3 in this row then must be here because they can't put 3 in the circle. So that's good. Nice spot from Josh. So this is not a 2. So the 2 in the row is placed. That's here. Four, 5, 7. Hey, John, how you doing? 8 in column 4. Ah, this sees a 6, 8 pair, so that can't be an 8. So that's an 8. So that's not an 8. Which places 8 in the row. Very nice. Okay, so we see 1, 3. If this was a 7, we'd see 1, 3, 7, 8, 9. So that would work. If this was not a 7, we could see 1, 3, 5, 6, 8, 9, but that doesn't work. We need the 7 here to hide these two cells. We need to hide the 6 because we right now see if these were blank, we'd see 1, 2, 3, 4, 5 already. So this has to be the 7 in order to hide that. Someone said that. Eric, maybe? So it's not 7. I'm sure that's helpful. Let's see. How are we adding to 7? We can't use the 1, so we could do 2, 5, probably in any order. We could do 3, 4, the 4 here and a 3 here. This 3 clue is interesting because 9 can't go in either of these. So 9's over here. But 9 can't go here because then we won't see 2. So 9 is placed. And now this needs to be big enough that we don't see this cell. This is 4 or 5. No, 4, 5, or 7. Oh, it's not a 7. That's true. So 7 in this column goes here. This is 8. This is 6. That's not a 6. According to my corners, this is the only place for 6 in brown now. This 6 sees these. That 6 sees this one. This can't be 6 just because this can't be 3. So yeah, 6 in this column goes here. Wait, what? Oh, and brown goes here, right? So that's a 4. These aren't 4, that's not 6. Now how are we adding to 9? This is certainly not a 3. That's not a 4. That's not an 8. So 9 in salmon. 9 in salmon's in one of these two. Row 5, column 7 is resolved. Yeah. How's the error resolved? Oh, I can't put a 4 on it anymore. So it's 2, 7. That's not a 2, so that's not a 5. That's not a 7 now. Nine in row 1's up here. So that means one of these 3 is a 9, so that goes here. So these are from, well, one of these is a 7, which is maybe interesting, but the other ones are, so we need a 5, 6, 8 with the 9. Seven in row 7. Yep, that's placed, it's here. That's not 7. Okay, so now it's just 5 or 8 with the 9, so that can't be 6. 9 in row 3 is now here. Nice. I feel like we're almost done with the 9s. We need a 9 here. And we need a 9. Oh. I think this has to be 9 for... Oh yeah, 9 in green, I guess is the question. Or just 9 in this row. Can't go here. Can't go here, here. Yeah, 9 in this row is the answer. That's there, that's there. These are the same digit. So for the row, we have 1, 2, 3, 4. We need 5, 6, and 8. So the 5 goes here, apparently. That's 8, that's 6, that's 8. 4, 5 pair puts a 7 there. This is 6, so this has to be 2, 4. Which makes that a 3, and that a 5, and that a 6, and that a 4. Nice. 2 and 5 make 7. That's 2 and 4 now. Sven is helping. All right. This is whatever's left for salmon. Looks like a 3. Places that 3. Places that 3. Okay, for corner marks. We need a 5 and an 8. Goes this way. In salmon, we need... No, this isn't salmon. This is like pink. We have 1, 2, 3, 4, 5, 6. We need 7 and 8. 7 and 8 going. These are done. We need... Hold on. We have 1, 2, 3. We need a 4. We need a 5. And we need a 7. Okay. Nice puzzle, riffclown. Just finishing up. Let's see. 1, 2, 3, 4. We need 5 and 6 here. That's 6, that's 5. And then we need a 2, 5, and 6. So 2, nope. This is 6. We need 2 and 5. That's 5, that's 2, and we're done. Hopefully that's the correct solution. We can look at this. 6, 8, 9 works. 7, 2 works. 1, 2, 3, 4, 6, 7, 9 works. 6, 8, 9 works. 7, 9 works. 5, 8, 9 works. Yeah, I think we're good. Sven to the end. Yep. STTE. Thanks, riffclown. Oof, we got like an awkward amount of time left again. Do I steal another 6x6 from Zetamath? Anyone in chat have a 6x6 in Zetamath's channel that you'd like me to try? Nope, no one? All right, I'll pick one. We'll do another Ambrose puzzle. All right, this is called Entropic Kropki Pairs by Ambrose. We've got standard 6x6 Sudoku Rules. Kropki pairs, so white dots are consecutive, black dots are 1:2 ratio, not all dots are given. Entropic lines along an orange line, any set of 3 cells in a row must contain 1 low, 1 mid, 1 high. All right, so let's color the big one. So let's go 3 colors here. Blue, green, purple, blue, green, purple, blue. So we know there's 2 blues down here. And if one of them's on a white dot, does the other have to be on the white dot? Not necessarily. The black dot can be anything but 5. All right, there are only 2 blues. So we need 2 blues down here, and they're here. So this is going to be... I don't know what color is consecutive with blue, but it's going to be one of them. If blue were 3-4, then either one of the colors could be consecutive with it. But these are both consecutive with blue. Does that mean blue has to be mid? I think that means blue has to be mid because there's 2 different digits that are consecutive with 2 different blue digits. So these are mid. So blues are 3-4. And these are from 2-5. So these are from 1-6. We need another green in this box. This is a green-purple pair, so we have no more greens in this column. So that means that these have to be green. So this is a 2-5. There's a 1-6 pair down here. We do need another blue in column 4. It has to go here. Good spot. This is the other 3-4. This has to be purple just for the box. So that means this is green. So if that means that this has to be purple because it's not the same parity as the other 2-5. So that's green. So now we're done with greens in this column. So neither of these are green. We knew that. Neither of these are green. This can't be the purple that's able to be on a white dot. Because if this were purple, it would have to be the other, it would have to be 2-5. Only one purple goes on a white dot. So this can't be purple. This has to be blue then. So it can't be green, it can't be purple, so it must be blue. That means that this is purple, and it's the 1-6 purple. This is 3-4. And so then this is a 3-4 pair, right? Can I color the 3-4s yet? Only kind of. So this is a 1-6 purple. 5 goes down here. I wonder if that's interesting. This is a 2-5 purple. So this is a 1-6 purple. So this is a 2-5 purple. This is the 2-5 purple. Oh, Entropic line. Oh, right. So this has to be purple and this has to be blue. We do know the. So this is 3-4. This is 1-6. Interesting. So we need a 1-6 green and a 2-5 green down here, which is obvious. This is the purple 2-5. So purple 2-5 now goes here. This is purple 2-5. So this is green 2-5. So this is green 1-6. This is green 2-5. Okay, so these two go on the black dot, and the only way to do that is 3-6. So this is 3-6. So this is 3-6, and now we are off to the races. This was really neat. I love these little ideas in the 6x6s. No? What'd I do wrong? It's working, isn't it? Oh, I broke this cell. So the question is, why was this one 2-5? That might have been the mistake. We know this is green. We know this one's blue. So we need a green-blue that have a 1-to-2 ratio. So these have a 1-to-2 ratio. So this is the 3-4. So we either have 3-6 or we have 4-2. This is a 2-6. Which means this green is 1-5. We created an asymmetry here. This is 1-5. This is 1-5. This is 2-6. We have a 2-5 pair here, so this has to be 1. These are 6s. These are 2s. That's a 1. That's a 5. So the purple 2 5s are 5s. That's 4, 3, 4. Okay, this is hopefully better. Okay, now we just finish. This is 1 and 3. This is 2 and 6. And we're done. Nice. I'll color it. These are green. It's blue. It's purple. Nice, I like that. And that took a good amount of time for the end of the stream there. Thanks everybody for hanging out. Thank you to my super supporters. The Asylum, Peter, David Ratner, Sotek, Franco, Jonathan, Mathgeek, Kenny, Aiden, Logan, Woofer, and Rise to the Equation. Thanks to all my members and patrons. Next stream is Monday evening for Word Games. If you want the next Sudoku stream, that's going to be Thursday evening. So hope to see you at one of those. And yeah, I'll see you next time.